Well, I know that several of you are still finishing up the drawings and adding datums to those. We're going to keep going and add a little more to that. So if you're still working on those, please push pause on that for a few minutes while I show you the next thing that we're going to work with in geometric dimensioning and tolerancing. And I alluded to this last time, but now that we have located datums, now we're actually going to reference them. So the three tolerance types that we're going to talk about today that reference those datums. Hopefully this doesn't crash on me. Not a good sign, huh? There we go. Maybe. There we go. Okay. So parallelism, perpendicularity, and angularity. And the one thing that each of these things have in common that the straightness, excuse me, and the flatness didn't, is that they're all relationships between two things. Straightness, it was just straight. Flatness, it was just flat. But here I'm talking about something being parallel to something else, or being perpendicular to something else, or being within a certain angle, to something else. Excuse me. So, when calling out something like an angularity, now we'll have the angularity symbol, and we've got our tolerance value, and then we're referencing a datum. So datum A is called out as the bottom of this part, and we're showing that it is 2/1000ths in relation to datum A. Notice I've got my angle dimension here of 30 degrees. Notice it has a box around it. We'll talk more about that in just a second. But just conceptually what this means, kind of like with the straightness and the flatness, is we're going to have a tolerance zone of 2/1000ths around this edge, and this edge is at a 30-degree angle, so this can float anywhere within there and have a resulting change in angle as long as it's in that tolerance zone. The 30 degrees is in a box. The reason why it's in a box is it's what we call a basic dimension. And a basic dimension means that you do not apply any title block tolerance to it. So a reminder that when I have a drawing and I must not have, I don't know why I'm not showing my templates there. That's weird. Give me a second, let me see if I can get to my S drive. Okay, I can. Shortcut's not working for some reason, but that's okay. So we've talked for several drawings how we've had a model dimension, and then we've also had our tolerance that would usually be tighter. I want to remind you that typically in title blocks, we'll see something like this, where we have a tolerance unless otherwise specified. So if it's 1 decimal place, it's plus or minus a tenth, and so on. So the basic dimension, the rectangle around it, is telling us not to apply any title block tolerance to it. It's just a straight up 30 degrees. All the tolerance is going to come from this angularity tolerance. So does that make sense? So if we look at another example of the angularity, this one's a little weird because they're calling out the hole in the cross-section view, but nonetheless they're applying it to a feature. And so remember, when we apply it to a hole or a cylinder, we're talking about the axis itself. So it's saying the axis has an angularity tolerance of 2/1000ths in relation to datum A. And then just like with the straightness on a feature size, the resulting shape is going to be cylindrical, just like I showed you guys last week on the straightness. So therefore we've got to put in the diameter symbol if we're talking about a cylindrical shape. And again, basic dimension with the box around it. So all tolerance comes from the control frame. And that's just a visual explanation. They're just showing you the little cylindrical shape as we've talked about. So to recap a few of those things, you have to have a datum. You can't just have angularity. You got to reference it to some datum. Can be to a surface or a feature of size. And it can use a material condition. So it can be MMC or LMC or regardless of feature size. Perpendicularity. So again, I'm talking about two things related to each other. Here I've got a hole, or actually we'll ignore the hole for now. I'm sorry, we're just doing the right side of the part. So the right side of this part is perpendicular within 2/1000ths to surface A. So obviously no diameter shape there. I'm just talking about a surface being perpendicular to another one. And once more, it is two parallel planes 2/1000ths apart, and it has to fall within that area. So not too different from the straightness, it's just this time we're relating it to a different plane. If we just had straightness, it could be straight but not necessarily perpendicular to this surface. So here we have perpendicularity applied to a feature, and once more when we're doing it on a cylindrical feature, we're basically applying it to the center axis. And so since we're doing it to the center axis, it's going to have a cylindrical shape and thus a diametrical shape. And in this particular case, it has the MMC applied, but again, we are perpendicular relative to datum A. So here's datum A. So again, got to have a datum. Can be a surface or a feature size. Will be a cylinder if it's on a cylindrical shape, and we can use MMC, LMC, or regardless of feature size. Very similar for parallelism. And then to see it applied, as you'd probably expect, here's datum A over here on the left side. This surface over here is parallel to datum A within 4/1000ths. So again, just a tolerance zone of a couple of planes that it has to fall within. Now this one is referencing a feature of size. So it's actually saying the axis of this cylinder has to be parallel to the axis of this cylinder. And I'm saying cylinder, they should be holes since they're called out in this view. So as you can see, the datum A is hanging off of the call out for this hole. So the axis here is datum A. This axis has to be parallel to that one within 4/1000ths, and again, it's going to give it a cylindrical shape since we're dealing with an axis. So again, just a side view of what we're talking about and the little tolerance zones in there. So we're going to add a couple more drawings to this, but I want to show you a few things first. And the first thing I want to show you is how do you make a basic dimension. So if I have a dimension in here and I want to put a box around it, the easiest way is through properties. And again, you can do CH or PR or right click and choose properties. And if I scroll down to the tolerance area, for tolerance display, we've done symmetrical and deviation and limits. There's also basic. So you could set that up as a separate dimension style if you wanted to. I think it's just as easy to override it in properties personally. But if you want to create your own dimension style, you could certainly do that. Let me show you what that looks like. So if I were to take this to places one and do a new 2 places basic, and then I'm just going to go to tolerances and set the method to basic. So if you want to do that, feel free. That just means now that I have a dimension style, and now I can actually have that from the start. And if I don't want it, then of course I can just change it into the 2 places. So my intention was just have you change in the properties, but feel free to make your own style. But keep in mind we're always starting with the same template over again, so you might have to do it each time. It's probably easier just to override it in the properties. So let's look at the 2 that we're going to add on today, and they are on page 606. And pretty simple shapes in terms of drawing, just a lot of annotating to do on these. So let me talk through the first one here. It says surfaces A, B, and B are datums A, B, and D respectively. So just because they're called out with a letter doesn't necessarily mean that they're going to be a datum though. So for example, see how there's a surface C here? Don't call that out as datum C. You're not told that it's a datum. This is just a reference later in the notes. So A, B, and D are going to be your datums. So we've got the back being perpendicular to the bottom within 0.01, and also flat within 0.008, so you'll have two tolerances to put on that. And then the top is parallel to the bottom within 0.005. And then surface C has an angularity tolerance of 0.008 with the bottom. So let's look at that real quick. So here's surface C, and it is an angularity tolerance of 0.008 with the bottom. So we're not told that they're MMC unless otherwise specified, so you won't put the MMC on it. You won't put the diameter symbol because that doesn't make sense. We're just talking about the angularity between two surfaces. But what you will need is when you dimension this 30 degrees, that needs to be a basic dimension with the box around it. And then the bottom has a flatness, the sides of the slot to be parallel to each other within 0.002 and perpendicular within 0.004 with the back. One side of the slot is to be datum E. So with that, just pick one side, either this side or this side, let's just say that one, and call that out as datum E. And then the other side, put in a parallel control to be within 0.02 of datum E. So make one datum E, make the other one parallel within 0.002 to datum E. Say that again. I'm sorry, this darn printer, I can't.
Edge view.
Edge view, yes, thank you, yes. Your datum should be shown in edge view. Yes, absolutely. Sorry, I need to shut this 3D printer down, it's noisy. Okay, the one down here at the bottom, very similar stuff. It's metric this time, but it should work just fine, just like you've been doing. The one thing I wanted to show you that's a little different is the third bullet here. Surfaces F and G of the dovetail. So if you look over here, here's F and here's G. They are to have an angularity tolerance of 0.05. So since they're going to have an angularity tolerance, these two need to be basic dimensions, right? They need to be in boxes. Within 0.05 with a single datum established by the two datum features D and E. So here's datum D, you'll call that out as datum D, and you'll call this out as datum E. But then in the control frame, when you're controlling the angularity, back on page 534, is where it shows how to call out multiple features creating one datum. So here's datum A, datum B. This is parallel within 0.004 of a plane caused by datum A and B. So in the first datum box, you're going to put A-B. Now you're not going to put them in separate boxes because again, that tells me there's a primary datum and then a secondary datum when we're locating everything. So don't put them in two different boxes, put them in the same one separated by a hyphen. And again, that's on page 534. Feel free to make yourself a note there if you need to when you get there. All right, so if you still need to finish up the datum drawings, go ahead and do that, and then transition into these. They will be, rather than a one to open up to start with, we're going back to using our templates. So you'll use your HCC ANSI or your HCC ISO, and then they should fit on B size. If not, you can always go up to C size. All right, let me know if you have any questions.